So let's survey some of the relevant RFCs to the host role in IPv6. First off, we have to determine which address we're going to use, because we've said IPv6 over IPv4, but which IPv6? Again, what we're going to look at is a set of rules that are put out in RFC 6724 that helps us with default address selection. So the first thing we look at is scope. We're going to determine whether we have a local, a EULA, administratively domain scope, or a global scope. So we're clearly going to use a global address to communicate with a global destination. But if we need to communicate with a local destination, we'll use the local address, and so on with the EULA address space. Next, we'll check the state. As we said earlier, we'll prefer a preferred address over a deprecated address. Then we're going to look again at the class, not necessarily the scope, but the class, to determine whether we have a native address. And if we have a native address, we'll prefer it over a transitional address. Now, transitional addresses are things we use in some of the adapters that support v6 tunneling over v4 protocols. Finally, we'll look at the type. And in most cases, we'll prefer temporary over public. But if all we have is a public and we're looking to send something outbound, we'll certainly be able to use the public address. Some other considerations for a dual stack environment. In this particular setup, we have a dual stack host with a DNS server connected to v4 and v6 networks. The host does a query, and when it does this query, it asks for either IPv4 or IPv6 or both records. And it really doesn't matter what protocol these queries are made over. They can be done in parallel or in serial. The host will receive that DNS information, an A record for the IPv4 address, and a quad A record for the IPv6 address. So now the host is going to try and make a connection request. What would typically happen is the host will prefer that IPv6 address. So let's assume that you have IPv6 connectivity in your organization and the destination has a quad A record, as we see indicated here. But what if the IPv6 network is broken somewhere in between the destination and your dual stacked network? Your host here will send a TCP SYN request to the address in that quad A record. It'll wait 7 seconds for the SYN ACK to return, send another SYN, wait 7 seconds, send another SYN, wait 7 seconds, and then default to the A record. That was the typical default behavior of a dual stacked host for many years, and in fact it caused a lot of problems with deploying IPv6 because, quite frankly, nobody wants to wait 21 or 40 seconds for the timeout process to occur. What we usually had in that case was some rather upset user communities. So a couple folks got together and developed an RFC to overcome this problem. It's RFC 6555, known in the industry as happy eyeballs. The intent here is to keep the user happy. And the way we do that is we give IPv6 a 300 millisecond head start on the TCP SYN. So we'll send out that TCP SYN to that address in the quad A record, and then 300 milliseconds later, we send out a TCP SYN over the address in the A record. Whichever protocol returns the connection first, we'll use for the rest of that particular session. Thus, the eyeballs are happy at 300 milliseconds, where they wouldn't be so happy at 21 seconds.